Hello students. Today we're going to talk about writing a quadratic equation by using 3 points. NASA can create weightless environment by flying a plane in parabolic paths. The table shows heights h in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. So the way that you were instructed to do this is by creating 3 systems of 3 variables and then solving it in order to find the equation. So the way we would do that is by saying if we have an equation in standard form, it would be height is equal to a times time squared plus b times time plus c. So if we use 3 of these values here, what we can do is say the height is 26,900 and that's when time is 10 seconds. So that would be a times 10 squared plus b times 10 plus c. And then we could do another equation where we said 30,600, no, let's do them in order. 29,025 is equal to a times 15 squared plus b times 15 plus c. And then 30,600 equals a times 20 squared plus b times 20 plus c. Now, we can multiply that out and we will get a system of 3 variables, and then we can use substitution and elimination to solve it. And if you're really excited about doing that, please feel free to do that. However, since we've done systems before, we know that this is a very long and drawn out process. Since we have access to technology tools, let's go ahead and use our tools to solve this one. So I'm going to go over here to Desmos, where I've been tinkering around already. I'm going to add a table, and I'm going to say for x1 is all my times. 10, 15, 20, 25, 30, 35, 40. And then my y's, 26,900, 29,025, 3,600, 31,625, 32,100, 32,025, and 31,400. Okay, now let me maximize this so we can look at it. I'm going to adjust my x and y axes. So I'm going to go from 0 to 50 on the x. And then on the y, let's go from 25,000 to 35,000. Okay, so looking at that now, you see a pretty strong parabolic pattern. So I'm going to go ahead and use quadratic regression in order to see what the best fit line is here. So the formula for quadratic functions in standard form would be y equals ax squared plus bx plus c. And I want to know what a, b, and c are. Now, that's not working exactly for a couple of reasons. First of all, I'm using x and y, but in my table it's x1 and y1. So I'm going to say y1 is equal to ax1 squared plus bx1 plus c. And again, it's not giving me anything. In fact, my table's disappeared now. And the reason for that is to do regression, we can't do equals. We need to say approximately. So I'm going to erase this equal sign, and I'm going to put the approximately sign. And there you can see it perfectly lines up right here. I see that my R value right here is 1, which, if you remember the correlation coefficient, means it's a perfect correlation. It hits every single dot in the graph. So after all that, I see A is -11, B is 700, and c is 21,000. So we can say that the formula is h is equal to negative 11 t squared plus 700 t plus 21,000. So that is the formula for height. And now the next question is, write and evaluate a function to approximate the height at which this occurs. Well, the problem says that after 20.8 seconds, passengers begin to experience a weightless environment. So all I need to do now is plug in 20.8 seconds for time. The height equals negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. And then, of course, I should be doing this with a calculator. Negative 11 times let's put that in parentheses, 20.8 squared plus 700 times 20.8 plus 21,000 is equal to 30,800.96, and this is a word problem, so we express the answer in words. We would say passengers will experience weightlessness at a height of 30,800.96 feet.